Hi guys, I am not here today. Going home this afternoon because I feel like crap. So, but I did want to go over some of the important parts of your test because you're going to be taking the next round of that next time, that fully factoring and finding the roots, and then using the remainder theorem to determine if a value is a root, and then confirming it with the area model, long division, or synthetic division, or all three for highly proficient. This means that you need to be very, very clear on the difference between the factor and the root. So for example, if something has a root of x equals 5, then the factor needs to be x minus 5. On the other hand, if I have a factor of 2x plus 3, then my root, and you can look at that in terms of parentheses, is not negative 3. A lot of people made that mistake on the test. The root has to be found by 2x plus 3 equals 0. Subtract 3 from both sides, so 2x equals negative 3. Divide by 2, running out of room at the bottom. So you have a root of x equals negative 3 over 2, or negative 1.5. So make sure you understand that difference and make that clear in your notes. You may use, again, a one-sided single page of notes on the test on Wednesday/Thursday. So I want to review how to factor quadratics because some people were able to do the initial factoring and then got stuck on the quadratics part. So for the first step, we put your first term, 2x squared, and your last term, negative 24. We take those two and we multiply them to get the top number. So that is negative 48x squared. Then we take our middle term, negative 13x, and we put that on the bottom. So I'm going to go to the next page and show you the next part of this. So we have our 2x squared, our negative 24. We have that multiplied, negative 48x squared, and negative 13x. So we need to figure out what multiplies to give us our top number, and adds to give us our bottom number. So if we don't know what that is, we need to factor the top number. So we start with 1 and 48. 48 divided by 2 is 24. 48 divided by 3 is 16. Yep, 16. 48 divided by 4 is 12. 48 divided by 5 is not a whole number. 48 divided by 6 is 8. It's not divisible by 7, and then we're back to 8 and 6. So we know that we factored we have all of our factors there. Now, what we do have to note is that these two are multiplying to give us a negative, so that means one of the two lists here is going to be negative. Because our bottom number is negative, that means they add up to a negative, so that means our bigger number is the negative. So then we add all these pairs together, 1 and negative 48, 2 and negative 24, 3 and negative 16, and 3 and negative 16 is the one that works. So 3x and negative 16x. And those go into our empty boxes. Doesn't matter which goes where. So 3x and negative 16x. So I want to pop all that in and go to the next one. So 2x squared. And I think I swapped which ones went where. Hang on. Okay, switch those now to avoid the confusion. So then once I have all these boxes filled out, I need to figure out what goes along here, so what my factors are, what factors multiply together to give me all this stuff. And to do that, I look at a column or a row to figure out my greatest common factor. 2x squared plus 3x, the most I can take out of both of those is an x, because 2 and 3 don't have a common factor other than 1. If I look at the negative 16x and the 2x squared, both 16 and 2 are divisible by 2. So I'm going to take 2x, divide 2x out of the bottom. 2x times 1x gives me 2x squared. 2x times negative 8 gives me 16x, and this is where a lot of people made a mistake. They assumed that this number was just negative 16 or whatever that number was, but you have to divide it by the 2x. So negative 16x divided by 2x gives us negative 8. X times 3 gives us 3x, so that creates that part. So that gives us our factored form of x minus 8 times 2x plus 3. Talk about the roots on the next page. Don't need that anymore. So my factored form, So my factored form is f of x equals x minus 8 times 2x plus 3. What I'm really using here is the zero product property, because y equals 0 at all of my x-intercepts. Then I can set each one equal to 0 to solve that. Now this is where a ton of people screwed up and did not get proficiency on their last test. So x minus 8 equals 0, add 8 to both sides, x equals 8. I don't expect that work to be shown, I'm just showing you that's why it is. It's why the root and the factor are often, but not always, opposites. 2x plus 3 equals 0 is where a lot of people screwed up. So 2x equals negative 3, divide by 2, so we have x equals negative 3 over 2. So those are our roots when we have factors that have something other than 1 in front of the x. And that's important to understand because you cannot get your full proficiency without that. All right, so let's go through this process with this is just one from your worksheet that you would hopefully finished. If we have, it gives us a factor of x minus 8. So we start with our first term, 3x to the third, divide out 3x squared, because we know that's what that 3x squared times x gives us 3x to the third. And we follow the pattern, factor, multiply, subtract. And we referred to this before as missing term, but really what you need to do is subtract. Factor, multiply, subtract. So we factored, now we multiply negative 8 times 3x squared, negative 24x squared, and then subtract negative 34x squared minus a negative 24x squared, and that gives us a negative 10x squared. Again, factor, so now we factor out a negative 10x, multiply negative 10x times negative 8 is 80x, and then subtract 83x minus 80x. So this is where I'm getting these. 83x minus 80x is going to give me what goes there. So 3x. Again, factor out the 3, multiply negative 24. And because that and that are the same, we know we're good to go. So that gives us the partially factored form. X minus 8 times 3x squared minus 10x plus 3. Then we factor that remaining quadratic. 3x squared, first term, last term of 3, that gives us 9x squared on the top. Factors of 9 are 1 and 9, not divisible by 2, and then we're at 3 and 3. So because our middle term, negative 10x, is negative and our top number is positive, we know both terms are going to be negative. So our factors there, negative 1x, negative 9x. So then we factor out. So I'm going to factor out the 3x from this column. Oops. Times x to get 3x squared, times negative 3 to get negative 9x. X times negative 1 gives us negative 1x, and then negative 1 times negative 3 gives us positive 3. So our fully factored form, we need to bring in that x minus 8 from the first step, x minus 3, and 3x minus 1. That means our roots are 8, 3, and to get that last one, we need to do 3x minus 1 equals 0. Add 1 to both sides, and I'm showing you this again because that many of you screwed this up on your test. Divide by 3. So x was 1/3. So the next part of your test was determining if a value is a root of a given polynomial. The first thing that we're going to use is the remainder theorem. This was one of the 2 requirements for your test. So plug in negative 2 for all of our x's. And we don't need to make it opposite because it tells us the root, not the factor. Remainder theorem uses the root, so we might want to make note of that. And then we evaluate. So negative 2 to the 3rd power is negative 8, plus 6, negative 4 squared is positive 4. And then I'm going to drop everything down. Just do the exponents in one step. Negative 8 plus 24 minus 10 minus 6. And what we get is 0. And that tells us that, yes, this is a root. I should say more specifically, x equals negative 2 is a root. So the area model is the next method. And here is where some people did not get their highly proficient. I'll show you why in a moment. So this uses the factor. So if the root is negative 2, the factor is x plus 2. X to the 3rd, factor out x squared, 2x squared, 6x squared minus 2x squared is 4x squared, factor out the 4, x, multiply again, 8x, 5x minus 8x is negative 3x, factor out the negative 3, negative 3 times 2 is negative 6, and that matches our last term. Now, if this was not a root, then the remainder would be the difference between the two. And a lot of people did not verify that. And had done something wrong in that process and would have noted that. Since the difference between these two terms is 0, then we know that it is a root because there's no remainder. But on your test, it was not a root, and you had to show that remainder. So, because you were confirming your remainder from the remainder theorem. So long division is up next. That one also uses the factor. The process is exactly the same as the area model. in that we use the factor, multiply, subtract sequence. So this would be x plus 2. So factor 3x to the third times, x times x squared gives us x to the third. Multiply x squared times 2, so 2x squared. Subtract 6x squared minus 2x squared is 4x squared. Drop down the 5x. So factor, we add the drop down part. Factor, we multiply x by 4x to get 4x to the third. So plus 4x. Then we multiply again. So 4x squared plus 8x. Then we subtract negative 3x, which should look familiar. Drop down the negative 6. And then we factor again. So this is negative 3. Multiply again, negative 3x minus 6. Subtract again. And we should get 0 for our remainder, which confirms our answer to the remainder theorem. If we get something other than 0 at the end of this whole process, then we've either done something wrong, or we should get our remainder that we got from the remainder theorem if it's not a root. All right, finally, synthetic division. Wrong function. This uses the root, not the factor. So we take our coefficients, 1, 6, 5, and negative 6, keeping in mind that everything has to be in order on that. And then the root of negative 2. Drop down our first one, multiply. So negative 2 times 1 is negative 2. We add, 6 plus negative 2 is 4. Multiply, negative 2 times 4 is negative 8. Add, 5 plus negative 8 is negative 3. Multiply again, negative 2 times negative 3 is positive 6. Add again to get our remainder of 0, which again confirms our answer to the remainder theorem. If we had a remainder, then that would be the exact same number that we got for our remainder on the remainder theorem. So, hopefully you guys are getting enough practice. I've left a short review, but again, biggest thing is finish AA3-5 and AA3-6B. So I will see you guys on Wednesday, and hope you're ready for your test.